Okay, welcome to Unit 5, Lesson 9. What is a logarithm? Let's learn about logarithms. So, on the calculator is this little key called log. I keep doing that. I'm sorry. I keep thinking I have the pin up. Next to the 7 button on your calculator, there's a button called log. This is what we're going to talk about today, and we're going to use the calculators exclusively. Okay, let's solve these. We know that 4 squared equals 16, so A has to equal 2. B, 4 to the 1/2, or the square root of 4, which equals 4 to the 1/2, equals 2. So B is 1/2. Now to the 5/2. The root of 4 to the 5th, or the root of 4 to the 5th, which is easier to calculate, which is 2 to the 5th, which is 32, equals C. Now, going by our 2's, we know 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64. 56 does not fall on that list that I wrote. Now, this is what we're learning about today. D is what? D is some number in between 0, 1, 2, 3, 4, 5, and 6. It's in between 5 and 6. This is where D lies. We don't know what it is, but we're going to figure it out today. Now, what you see here is a log table, and I had to use these log tables back when I was a kid. And thank God you guys got calculators, so you don't have to look at tables and interpolate the numbers. So let's look at the table. This says log. Log base 10. The base is 10. That's why it's written as a subscript. That's the base of the number x, which is the answer, equals the exponent. Now, what logs do, because the numbers get so large very quickly, look at our x values. If we was plotting this on a piece of paper, if we start at 2, we get 0.3. But we have to go all the way to 10,000 to get to 4. So logs look like this, where they take a long time to grow. So instead of using XY tables, instead of doing that, what we do is we're going to count the exponents. And that's what logs do. They count the exponents so that the numbers get close enough together so that we can see them. That's basically what we're doing. So now, use the table to find the numbers. So W equals 3. Now, these are approximations. We know that roots of non-perfect numbers are irrational, which means they go on forever. What we're going to do now is, I've been telling you in the last couple lessons, we're going to round to 4 digits after the decimal. So we're rounding. So to get Y, we look for 9 when X is 9, 0.9542. 10 to the first power is 10, so we would expect 10 to the 0.9542 power to be 9. Well, it's way more numbers than that, but we don't know because we rounded to 4 decimals. So if you put 10 to the 0.9542, you would get really close to 9. You wouldn't be at 9, but you would get really close. And then Z, we look at 90, which gives us 1.9542. If we put 10 to the 1.9542 into the calculator, we would get real close to 90. Okay, let's look at question 3. Notice that some values in the columns are whole numbers, but most are decimals. Why do you think that is? Because there's only a certain amount of perfect numbers. Okay, so logs count exponents. What does that mean? These numbers 2 and 3 are the exponents. 10 is the base, and these are the answers. So if I was in exponential form, it would be 10 squared equals 100, and 10 cubed equals 1,000. So the beautiful thing about log base 10 is if the number starts with a 1, all you got to do is count the number of zeros, because remember, on next to the log goes our answer. On the other side of equals goes our exponent. So count the number of zeros. 1 million has 6 zeros. 1 has 0 zeros. Now we're given the exponent. We don't know what the answer is. So just take a 10 and put, or take a 1 and put 7 zeros after it. So 6 more zeros. That's not 7 zeros. That's 6 zeros. 7 zeros. Nope. That's 10 million, not 100 million. I'm sorry, people. 1, 2, 3, 1, 2, 3. I messed that one up. So that should be a 1 with 7 zeros behind it. Okay. Estimate the value of log base 10 of 610. Go back up to the table. Look for 600. I don't know if 610 is going to be on there, but if we use the other log charts, they had every number, and we had to read all those through all those pages of charts. So log base 10 of 600 was 2.7782. So log base 10 of 610 is going to be bigger than 2.7782. It could be 2.7785. I don't know. It's just bigger. So log base 10 of 610. And in the next lesson, I'm going to show you how to use the log button on the calculator. And then you don't ever have to worry about looking at charts again. Okay. The term log is short for logarithm. Discuss the following questions with a partner and record your responses. What do you think a logarithm means? It does. Logs count exponents. Next to log is a subscript. That's subscript means written below. Sub means below. And script literally means writing. So the literal translation of subscript means writing below. And then a superscript written above, writing above. And that's the base. The base is the base. What about the other two numbers on the either side of the equal sign? For example, the 2 in log 10 base 100. What do they tell us? Okay, so this is your base. This is your answer. This is your exponent. Logs count exponents because it's easier to graph exponents than it is numbers because they grow very quickly. They grow very large very quickly.